Today, there are plenty of microcontrollers available in the market. The most notable among them are AVR's Atmega32, Intel's 8051, Microchip's PIC18 and PIC16 series, ARM's Cortex, Motorola's 6811, and C-Log's C8. Out of these, all other microcontrollers except ARM's Cortex are examples for 8-bit microcontrollers. The ARM's Cortex is an example for 32-bit microcontroller series. How to choose a microcontroller? There are certain criteria for choosing a microcontroller. The first criterion is efficient and cost effectiveness. A microcontroller should be a computer that meets our computing tasks at an affordable price. The second criterion is the speed and packaging of the microcontroller. We always go for a microcontroller with higher speeds of operation. This another important criteria is the packaging. Packaging becomes important when it comes to the assembly of the embedded product. A microcontroller may come either in a DIP or QFP. DIP stands for dual inline package. QFP stands for quad flat package. The third criterion is the power consumption by the microcontroller. It is crucial for battery powered embedded products. The fourth criterion is the amount of memory. The amount of ROM determines how much of code actually we can write for a certain microcontroller. And the fifth criterion is the number of input output pins, timers, and other peripherals. The most important criterion is the availability of the microcontroller and its development softwares. By development softwares, we mean the assemblers, compilers, or IDEs. A famous example for an IDE is the Arduino IDE, which supports the development of Atmega32 embedded products. Let's have a look at the history of the 8051. It was in 1981. 8051 was first introduced by the Intel Corporation. Intel called it MCS51. Later, Intel allowed other manufacturers to make and market 8051 with a condition that these microcontrollers made by different manufacturers should be code compatible with each other. By code compatibility, we mean that the code written for one manufacturer should work for the 8051 manufactured by the other manufacturer. The key features of the 8051 are it has an 8-bit database and 16-bit address bus, 128 bytes of RAM, 4 kilobytes of ROM, 2 timers, 1 serial port, 4 input-output ports, each 8 bits wide, 6 interrupt sources, and 8051 is a CISC microcontroller and it follows Harvard architecture. The major 8051 suppliers are Intel, Infineon, Atmel, Silicon Labs, Dallas Semiconductor, and Philips. All these companies make 8051 today. Let's have a look at the 8051 pin diagram. We will confine our discussion to a 40-pin DIP, dual inline package. There are 20 pins on the left side and 20 pins on the right side. And pin 40 is the VCC, pin 20 is the ground, pin 9 is the reset pin, pin 18 and 19 is for the clock, pin 31, pin 30, pin 29. All these pins are for the external memory access, and the rest of the 32 pins constitute the input output ports. These are the two packaging, DIP and QFP. DIP stands for dual inline package and QFP stands for quad flat package. Pin 40 and pin 20 are the VCC and the ground respectively. Between pin 18 and pin 19 we connect the crystal oscillator which supplies the clock. Pin 1 to 8 constitute port 1, leaving one pin on the left side. Pin 10 to 17 constitute port 3. Pins 39 to 32 is port 0. Pin 21 to 28 constitute port 2. Pin 9 is the RST or the reset pin. Pin 31, pin 30 and pin 29 are external access, address latch enabled and program store enabled respectively. Pins 31, 30 and 29 helps to access external memory when needed. What shown here is a block diagram of the 8051 microcontroller. A CPU works on the clock and it is shown connected to all other peripherals. There are three variants of 8051 in the 8051 microcontroller family. We have already discussed about 8051. In 8052, it comes with 8 kilobytes of ROM and 256 bytes of RAM. That is, the amount of memory is twice as that of 8051 and the number of timers is 3 in 8052. Number of interrupt sources is 8. Number of input output pins and serial port remains the same as in 8051. In 8031, ROM is absent, or 8031 has 0 kilobytes of ROM. So one has to connect an external ROM IC for storing memory, for storing the program. 8031 has all other features same as that of 8051 microcontroller. 8031 is called the ROM-less version of 8051. What is machine cycle? There are three major steps to execute an instruction by the CPU. They are the fetching of an instruction, decoding the instruction, and executing the instruction. These three steps constitute a machine cycle. The period of a machine cycle varies among different versions of 8051 from 12 clock cycles to 1 clock cycles. For an Intel NCS 51, which was the original 8051, one machine cycle is equal to 12 clock cycles. From the datasheet of the 8051 supplier, the number of machine cycles for each 8051 instruction can be obtained. The clock is supplied by the crystal connected between pin 18 and 19. For an Intel NCS 51, when a 12 MHz crystal is connected between pin 18 and 19, which are marked as XTAL1 and XTAL2, one clock cycle is the reciprocal of the frequency supplied by the crystal. So 12 clock cycles means 12 into 1 by 12 into 10 raised to 6, that is 1 microsecond. So one machine cycle means 12 clock cycles is equal to 1 microsecond when a 12 megahertz crystal is connected. This is how a crystal is connected to generate the clock pulses for the 8051. In the figure which is shown right side of the slide, a TTL oscillator is connected which supplies the clock. When a 16 megahertz crystal is connected, one clock cycle is equal to 1 by 16 into 10 raised to 6. So 12 clock cycles will be 12 into 1 by 16 into 10 raised to 6 is equal to 0.75 microseconds. So one machine cycle for an Intel MCS 51 will be 0.75 microseconds.